Hey there, it's Jason Gorman from Codemanship with a video about the testing pyramid for JavaScript developers. Now I'm going to refer back to the last video I posted on this channel, which is about continuous integration and continuous delivery. And what I wanted to draw your attention to is on the build status page for the little demo project I did. I want to draw your attention to this number here. The duration of the build. How long does it take to build the software? Now, this is a critical number in software development. It's one of the most critical numbers in software development. If your builds are slow, if they take 15 minutes or half an hour or 4 hours or 8 hours, I've seen some builds that take more than 24 hours, then that's going to slow this whole process of delivery down, which means it's a bit like the metabolism of your software development cycle, in the sense that if your builds are slow, if they take a long time, then that's going to have a knock-on effect to everything else. And in particular, we need to think about the lion's share of that build time is taken up with how long it takes to run your tests. So in actual fact, the most critical number in software development in terms of continuous delivery is how long does it take us to retest the software? How long does it take us to execute our test suite? And I've worked with clients where the answer to that is literally days. It takes days to rerun the tests. And the effect of that, the impact of that on us, not just in terms of software development, but the wider impact on the business that's relying on this software, whether it's a core product or whether it's an internal system that they're relying on for their operations, can be very profound. I've seen some big businesses brought down by, when you got to the root cause of it, very slow builds. The impact is, and therefore very slow tests. The impact of slow tests and slow builds is felt in all sorts of different ways. It means we're getting feedback from end users less often because we're able to ship the software less often, because at any point in time it's not necessarily shippable. We don't have continuous delivery. If tests take a long time to run, that has an impact on code quality as well, because it makes refactoring much more difficult. And if refactoring is much more difficult, we're going to do a lot less of it, which means our code is not going to be as maintainable. So it impacts us in all sorts of ways on the pace of iterations, the pace of innovation and delivery, and how long we can sustain that pace, how long we can keep making changes to the code without breaking it. So it is a very important number, and it's important for teams to invest in making sure they keep that number low as possible. And since the bulk of build times in most cases is running the tests, it's therefore important to make sure that our test suites run as fast as possible. So I've got a little slide prepared here. Imagine the distribution of our tests on a sort of an XY graph like this one, where we're showing how many tests we have compared to the execution time of those tests. So the distribution of tests by execution time, how long they take to run. Now what we're aiming for in terms of our test suites is a right way up pyramid. That is, the base of the pyramid, the bulk of our tests, run as quickly as possible. And at the top of the pyramid, have as few as possible slow running tests, so that overall we can run a whole test suite very quickly. Now, what kind of tests would therefore make up the base of our pyramid, the bulk of our tests? Well, I call them unit tests, but I'm going to qualify what I mean by that. I mean tests that do not involve external dependencies when they execute. So, for example, they don't read data from databases, they don't talk to web services or anything like that. So everything's happening in memory. So these tests, they run in milliseconds or fractions of milliseconds. So we can run thousands of them in a minute. And that should be the base of our pyramid, the bulk of our tests. We're also going to need some integration tests that necessarily do have direct external dependencies. So they connect to web services or they connect to databases and so on. So we need these tests. They're very important, but we want to have far fewer of them. If they take, say, 10 times as long to run as unit tests, then we would like to have 10 times less of those. And then finally, at the top of our pyramid, we would have some tests that essentially connect all the parts of the system together, including those external dependencies, and check that the whole thing works as a complete system. And we would want to have as few of those as possible. So what do our unit tests test? Well, they test the logic of our code. They ask questions like, are the mortgage repayments calculated correctly, and so on and so forth. Now, we could ask that question with a system test. We could, for example, write a Selenium web driver test that drives an app through a browser, clicks buttons, and then checks the result at the bottom. But that would be a very expensive and complicated way of checking that the mortgage payment is calculated correctly. Far better to actually unit test the component or the module that does that job. So a unit test tests the logic as much as possible, all the logic of our application. What about the integration tests? Well, they're not testing logic. What are they testing? They're testing the contracts of those conversations between servers and web services and databases and so on and so forth. So they're testing that the conversations that are taking place between our code and those external dependencies are taking place correctly. And these are very important tests, don't get me wrong, because a lot that goes wrong in software, a lot of the bugs in software turn out to be integration bugs. In other words, people breaking contracts. So you definitely do need these tests, but you want to have far fewer of them because they're going to take longer to run than your unit tests. So if we're testing the logic with unit tests and we're testing the contracts between the different components of the system with integration tests, what's left to test? Well, I use the example of testing a car. We might want unit tests for all the individual components, spark plugs and that kind of thing. But then we might want to assemble these components into subsystems and check that they work together correctly. For example, does the radio work within the car's electrical system? Ask those questions that we can only answer by plugging things together. And then finally at the top, once we've assembled all of those subsystems into a complete system, complete car, we stick the key in the ignition and we take it for a test spin, just to check that we have indeed built a car. The car works, it runs. So at the top, what we're checking really is the configuration, the overall configuration of the system. Does it work on this machine, basically? We try not to ask questions about logic in our system tests, although it may have those questions just for example, just for illustration purposes. Similarly with the integration test, they may ask questions about is the response correct and so on and so forth, but we are interested only in the conversations really. So we're aiming, when our logic is wrong, for a unit test to catch that. We're aiming when someone breaks a contract, for example, when Facebook changed their API again, we're hoping that our integration test will pick that up quickly. And with the system test, if something changed, for example, about the production environment, that means that our code is no longer running. Let's say, for example, they've changed the date system or they've upgraded the operating system and something's changed, like permissions on a particular folder that we're using, then that would show up with our system test. So we might have thousands of unit tests in a typical business application or a typical commercial product. And we might aim then just to have a few hundred integration tests that are checking how our code is talking to other people's code. And then finally, we might have just a few dozen really cherry-picked user journeys through a browser or whatever kind of system we've got, just to check that when we put it all together and deploy it into a certain environment, that it actually works as a complete system. But this doesn't come for free. You have to invest in this. And one of the things you need to invest in takes us back to another Codecraft video, which was all about design principles. In fact, there were two videos about them, about principles of simple design and the principles of modular design. So what I'm going to do is I'm going to show you some code to illustrate how these principles, when they're applied, can help us to achieve a testing pyramid that is the right way up. Because trust me, if your pyramid is upside down, you've got a real problem. Seen it many times. So let's take a look at some code. I've got some object-oriented JavaScript here. And what it's doing here is it's essentially calculating prices for movie rentals based on the IMDb rating of the movie. So if it's a high-rated movie, 7 or more, we add £1 to the price. If it's a low-rated movie, less than 4, in other words, if it's a turkey, we knock £1 off the price. And for all other movies, for average movies, we charge a standard price. And I've rigged up our little test harness here. I don't have any unit tests, but I've rigged up a little test harness. So I've got this little command line program here, and I can use this command line program to check that the prices are being calculated correctly using some test IMDb ratings, using some examples that I picked off IMDb. So let's take the high-rated movie first, and let's see if that is calculated correctly. There we go. Yeah, $4.95. That's what we're expecting. A bunch of other stuff happening here as well. You don't need to worry about that. But suffice to say, I'm confident that it's working for that. Now, I would want to test the other two cases. So what I've done, speed things up a little, is I've rigged up a little Windows batch file that's calling this command line program with 3 different IMDb IDs for 3 different ratings. So let's run our little batch file here. We should get 3 results back. Okay, and they're all looking good. They're all correct. Now, you will have noticed that those took 2 or 3 seconds to run. Just for those 3 tests. Just for those 3 tests, 2 or 3 seconds. Now, extrapolate that to a real system which might have thousands of these kinds of tests, and you've got a real problem. It could take an hour or more to actually retest the software. So what's getting in the way here of us writing unit tests for this code? Let's take a look. So our program uses a rental object, there we go, and it gives it the IMDb ID. The rental object builds itself in terms of the movie title and the price, and it uses a pricer object here, and that actually does the calculation of the price. So let's take a look at pricer, and here is the problem. This code here is embedded inside the pricer that connects to this external web service, that connects to this IMDb IPA and IMDb API. IPA is a beer, API is an application programming interface. That's how I remember them. Got to have a system. So it's connecting to that, and it's calculating the price based on the rating. So this is breaking our first principle of good modular design. This module is doing more than one job. The first thing we might need to think about is how can we break this down into 2 modules, each of which does either of those jobs. So let's take this code out. So this is the offending code here, the code that actually has the direct external dependency. Let's get it on its own. So I'm going to refactor this by extracting a method. Let's call it fetch info. IMDb movie ID. There we go. And now, nothing to do with what we're talking about, but here's a bit of advice. There are people, silly people, who will tell you that if you are refactoring code that doesn't have unit tests, and you're using the automated refactorings in WebStorm, for example, because those automated refactorings are guaranteed to preserve the behavior of the code, guaranteed not to break it, you don't have to retest your code. I can tell you from personal bitter experience that is not true. That's bad advice. These automated refactorings break code all the time, as we're about to see. But in this case, I think it hasn't. But let's just make sure and rerun those slow-running integration tests there. There we go. It's still working. That's good. Now, we've got it in its own method. That's a start. We want this method to be in its own class. So what I'm going to do, I'm going to cut that. And I'm going to imagine this class exists. Let's call it IMDb. And let's create that class. I'm going to paste in our method there. So that's a refactoring called extract class. And of course, I'm immediately, because I've done it manually, you see, immediately rerun the tests. Looking good. So far, so good. So it's in its own class. It really needs to be in its own file. So let's move that into its own file and replace it with an import. Call it IMDb. And let's create that file. Paste in our class there. Export it. Lovely. And again, immediately after we move that class, we rerun our test. So this discipline is very, very important. And imagine now that the tests take an hour to run. So you can kind of get the feel for how hard this is going to make refactoring if we have slow tests. Okay. Now we go back to our pricer. So we do have now a class that does that specific piece of work. And that's the first step. We make sure that each of our modules does one job. So we can test one job by itself. But we still have a problem here, and the problem is this. It's a direct implementation dependency. So we need to think about another modular design principle, and that is that modules should be swappable by dependency injection. So for example, we could replace this reference to the implementation of IMDb with a stub version of that returns hard-coded JSON for the purposes of testing. So what I'm going to do, first of all, is I'm going to turn this into a field. I'm not going to do the underscore thing. I would like to do it in the constructor, but it won't let me do that. So, okay. Thank you very much. And immediately retest. And again, just imagine that there were hundreds of these tests, how long that would take. Okay, and what I'm going to do is I'm going to do that in the constructor. Retest. Okay. What I want to happen now is I want this to be passed into the constructor to be dependency injected. So let's add it as a parameter. So, and hopefully you'll see as we go into rental, the client of this, being passed in and out. Here's the thing. When people say automated refactoring is guaranteed to preserve the behavior, they're guaranteed not to break the code. This has broken my code because this has not added an import for that. So I have to add that myself in order for this code to work. So that's why we don't rely on automated refactorings to guarantee that we don't need to retest. We retest regardless, even if we're testing it manually. Okay, so now the pricer is being injected into rental. Pricer no longer needs to know what implementation of IMDb it's talking to. It's somebody else's problem now. It's rental's problem. Let's go into rental, though. We kind of have, if we look at my little test fixture there, I'm actually testing rental. So we need to bubble this up a little more. So what if we pass the pricer, like Russian dolls, we pass the IMDb object into the pricer and then pass the pricer into the rental object. So we're going to produce that as a field. No, not movie. Selected too much there. It's just that we're interested in. Okay. Yeah. Adding that as the parameter there. Yeah, that's correct. So far, so good. And if we take a look in our program now, it's being passed in there. But again, broken my code. So let's import those as well. My laptop having a little think there. Okay, and we now should be able to retest. So we've externalized our external dependency in the sense that now it's only our test harness that knows about it. And that puts us in a position now where we could replace that with something else, like, for example, IMDb stub. So let's imagine we have this object now. And all it needs is a member that matches what our client is expecting, what the pricer is expecting, and returns whatever we tell it to return. In this case, it's some JSON. So let's stringify an object that looks like what they're expecting to receive. So it's going to have an IMDb rating. This is the data that gets returned from the IMDb API. And it will also need a title with a capital T. That's how they've done it in their output. And it doesn't really matter what the title is, but let's call it the Abyss. And now I can rerun this test, but it's not going to connect. This line of code will not connect to the external API. It will just use that JSON data that I told it to use in my test. So let's rerun our test. So you see now they're all coming out as the Abyss, and they're all coming out as 495. And they're running a little faster as well. Now we still have an external dependency here. We'll talk about that in a minute. But let's just focus on pricing for now. I would now be in a position to write fast running unit tests, say mocker tests, for this code here, for my 3 examples that I'm doing in my little batch file. I can redo those examples. We don't need to know what the IMDb rating is anymore because we're only interested in the actual the IMDb ID. We're interested in the rating, so we can simplify our tests a little bit as well. So what I'm going to do is I'm going to pause the video here, and then I'm going to write some mocker tests for this line of code here, for this part of the code, and we'll see how much faster those tests are without that external dependency. So here's my mocker test code that essentially reproduces those 3 pricing scenarios, an average movie, a good movie, a great movie, and a bad movie. And all we're doing is we're just passing in a stub version of this IMDb object that returns whatever JSON data we tell it to return. And these tests, well, let's see how long these tests take to run. If I run them using the test harness here. So it's about 0 milliseconds. It's less than 1 millisecond to run those 3 test cases. How much have we speeded up our test suite here? Well, what I've done is I've inserted a little bit of instrumentation code here to just measure roughly in milliseconds how long each of these integration tests is taking. So I've converted this back to an integration test here. It's using the real IMDb API. If I run these, see, we get some execution times there, depending on how busy that is. But yeah, they're in the order of almost a whole second there, hundreds of milliseconds. So our test suite, and that's for each of those tests. So we add them together, it literally is 2 or 3 seconds that it's taking. So we've speeded up the process of testing that logic roughly 1,000 times. Several zeros have been knocked off the end of that number. And that can have, if we amplify that, extrapolate that to thousands of logic tests, then that can have a really big impact on the shape of your testing pyramid as to which way up it is. So the modular design principle is very important, in particular making sure that each module is only doing one job so we can test that work on its own. And also making sure that modules have swappable dependencies, that we can swap modules usually by dependency injection so that we can stub them or mock them for the purposes of unit testing. But that from a design point of view also has other potential advantages, like let's say we don't want to get ratings from IMDb anymore, we want to get them from Rotten Tomatoes, then it would be much easier to swap out that source of data because our business logic does not directly depend on those details. So all good stuff, but still a bit of a problem. So there was a bit of code here that I've commented out, uncommented. There's another object here called ratings, and what that is doing is it's fetching IMDb profiles carry not just IMDb ratings, but a collection of ratings from other websites as well. So we got some code for retrieving that. Let's take a look at that code. Aha! Now, does that look familiar? Does that look familiar? Yeah, this code, and take a look in IMDb. This code, and inline that to make it a bit more obvious, are identical. And I know they're identical because I copied and pasted it. Another thing I see teams doing is essentially copying and pasting or duplicating code that has direct external dependencies, integration code. So it's reproduced everywhere, and that has 2 big impacts. One is it means you have to integration test everything, everywhere that code appears. But it also means if anything changes about the IMDb API, I've got to now change it in multiple places. So if you are, for example, using the Facebook API or Google Search API or whatever. And these companies, they have a nasty habit of changing their APIs, and you're just multiplying the cost, the impact on you when those APIs change. So you really want it to happen in just one place. So the principle of don't repeat yourself, dry, is very important when it comes to integration code. We don't need, in our where is it ratings class, we don't need this duplication of code. We can actually reuse IMDb ID. Let's assign that to a variable. So if we go back to our program here, I can retest this and it should still be working. No, it's not, because I haven't imported. I always forget to do that. Silly Jason, let's import that. DB. Now let's try it. This is why we need to retest our code, and it's why the tests need to run fast. Okay, so you can see now as I just maximize this, we're not just getting our rental information, we're also getting our list of ratings from other websites, including IMDb, as we intended. And what we could do again, as we did with the rental object, is we could pass this in rather than having it created here. So we could inject it. And that again makes it swappable by dependency injection for a stub. So we could unit test not just ratings, but anything that's using ratings, we can unit test that without hitting any external dependencies as well. So there's 3 design principles in particular that help us achieve a testing pyramid. The first principle is that each module should only do one job, so we can test that on its own. The second principle that's very important is that the module should be swappable by dependency injection. So in particular, modules that have direct external dependencies, it's imperative that they are swappable. It's often referred to as portable code. So back in the 90s, when we were trying to write C++ programs that would run on Windows and run on Unix, we got into the habit of making sure that all of our direct dependencies on the Windows API or the Unix API were abstracted away into classes that were injected in using C++ interfaces, so that we had an abstraction for the underlying operating system, and we didn't have to rewrite the core logic of our applications, because that would have taken a very long time. So modules should do one job. That's very important. Modules should be swappable by dependency injection, particularly if they have external dependencies. And we should not repeat ourselves. That if we're going to do something, particularly again when it involves external dependencies, we should do it in one place only. So we can, one, reuse it in all the places that we need to swap it, but also so that when that external dependency changes in some way, only one part of our code is affected. Potentially only one part of the code needs to change. So if we design our code in this kind of modular, duplication-free way, paying particular attention to those external dependencies, then we end up with code that is much more unit testable and suites of tests that execute in milliseconds or fractions of milliseconds instead of seconds or fractions of seconds. And that's a big, big, big speed up of hundreds of times or even thousands of times faster. And that's how you get a testing pyramid that is the right way up.